Welcome back. We are continuing our R.7 notes on radicals, radical operations, and simplifying radicals. We left off, we're on example 7, talking about adding and subtracting. So the key with our adding and subtracting is that we need to make sure that we have like radicals. We have the same root with the same stuff or expression underneath. So if I'm looking at example A, we have the fourth root of 11pq and the fourth root of 11pq. Because those are both the fourth root of 11pq, I'm allowed to say 3 minus 7 is negative 4, fourth roots of 11pq. Notice that when we add or subtract, I'm not changing anything underneath here. I'm only changing the coefficient out in front. Letter B. Well, we have a square root of 98x cubed y and a square root of 32xy. Those are not the same. So in order to be able to do anything with this, I've got to try to simplify those radicals. Well, 98 I know is 2 times 49, and 49 is 7 times 7. So we have a pair of 7s that can come out. 2 stays home. X cubed, we have 3 divided by 2. We have a 7 that's coming out here. 3 divided by 2 is 1, with 1 remaining. And then the y, I don't have pair to pull out of that, so I can't do anything with that. So we have 2xy sitting in there. We have a plus here. 32, I can do 4 times 8. 8 is 4 times 2. Remember, we're looking for pairs. I have a pair of 4. So I could break those down further, but I don't need to because the 4 can come out. The x and the y, they don't have any pairs that we can reduce those by, so 2x and y are staying. The 4 that pulls out, we are always multiplying, so 4 times 3x is 12x, and then we have 2xy left over. Now that I have square root of 2xy and square root of 2xy, those are both the exact same. The coefficients are 7x plus 12x. Those are also like terms. 7x plus 12x is 19x square root 2xy. We look at example C. Let's do yellow. Third root, these are, again, not the same. 64 I know is 4 times 16. 16 is 4 times 4. It's a third root, so I need 3. So I have a group of 3 4s. M to the 4 over 3, I can pull out one group of m's with 1 remaining. And then I have n to the 5 thirds. I can pull out one group of n's with 2 n's remaining. So we've pulled out all of the numbers and we have mn squared remaining. I want to do the same thing for this next one, the third root of negative 27. Because it's an odd root, a third root, I'm allowed to have a negative underneath there. 27, we have 9 times 3. 9 is 3 times 3. So I have a group of 3 3s. It was negative. So we're pulling out negative 3. It was subtraction here. We have m to the 10 thirds. I can pull 3 groups of m from there with 1 remaining. And then we have n to the 14 thirds. I can pull out 4 groups of n's there with 2 remaining. Now I have like radicals. They're both the third root of mn squared. Minus -3 is really plus 3. But when I look at the coefficients, mn and m cubed n to the 4th are not like terms. So I actually can't do anything more than what I've already done. And that's going to be simplest form because I've reduced all of my radicals. And then I can't condense things any further because they aren't like terms for my coefficients. Example 8 is more of the simplifying that we were doing earlier in one of the other examples. My base here is 3. My exponent is 2. My root is 6. Now it's only saying simplify, not evaluate. So it's not asking me to put this in my calculator and try to figure out an answer. 2 over 6, I can reduce to 1/3. And so that's 3 to the 1/3 power. Letter B, I have x is my base to the 12th power 6th root and y to the 3rd power 6th root. 12 over 6 reduces to 2 and 3 over 6 reduces to 1/2. So x squared y to the 1/2. Letter C. Remember, a root of a root, this is a second root next to the 6. So the first thing we're doing is when I have a root of a root, we said we would multiply 9 times 2. So that is the 18th root of 6 to the 3rd. My base is 6, my power is 3, my root is 18, and 6/18 reduces to 1/6. So 6 to the 1/6 power would be the simplified form. Multiplying. Multiplying, we can put anything together that we want to, but we can only actually multiply like things. For these, we'll be foiling, distributing, whatever operation makes the most sense for you. So I'm going to start with A. We have square root of 7 times the square root of 7. They're both square roots. 7 times 7 is 49. Square root of 7 times the square root of 10. Positive. They're both square roots. So I have a square root. I'm allowed to multiply the 7 times the 10 to get 70. Negative square root of 10 times 7. We have a negative square root. 10 times 7 is 70. And then negative square root of 10 times positive square root of 10, we have negative. 10 times 10 is 100. Like terms here, this is positive 1 square root of 70 minus 1 square root of 70. And when I add those together, they add to 0. The square root of 49 is 7. Minus comes from here. The square root of 100 is 10. And 7 minus 10 is -3. So that would all simplify down to -3. Looking at example B. Square root of 2 times the square root of 8. They're both square roots. 2 times 8 is 16. Square root of 2 times -5. Those are not like things, so we just make them sit next to each other. And remember, we always write that square root last. On the inside, I have 3 times the square root of 8. Again, the 3 is not a radical, so we just make them sit next to each other. And then 3 times -5 is -15. Now we need to start simplifying our radicals if we can. Well, I know the square root of 16 is 4. Square root of 2. I can't break 2 down into anything, so that's going to stay the way that it is. 8. 8 is 4 times 2. 4 is 2 times 2, so it looks like I can pull out a pair of 2's with a 2 stuck at home. 2 times 3 is 6. with the square root of 2, and then we bring down that minus 15. So now as I'm looking at my like terms, I have these two that are both square roots of 2 that are like terms, and then the 4 minus 15. So 4 minus 15 is negative 11. And then negative 5 plus 6 is positive 1 square root of 2. And that would be our final simplified answer. I cannot go any further because the 11 does not have a square root of 2 to be able to add those terms. This is where we are going to stop for today. Thanks so much for joining me. Have a great rest of your night.